Hi everyone, my name is Nien. Today we are going to learn the basics of machine learning. Let's get started. So there are three types of machine learning: supervised, unsupervised, and reinforcement. So supervised learning is that your data has the X as input and you have the Y as the label, the output, or say the target. So we feed the model with the data, and the model itself learns to map the input to outputs. So for example, if we talk about housing prices, x1 could be the region of the house, x2 could be the size of the house, x3 could be the number of parking spaces, and y is the housing price. Or in terms of weather temperature, x1 could be humidity, x2 could be air pressure, x3 could be wind intensity, and y is the temperature. Next, unsupervised learning. We have only x as data and there is no label as y as the target. So we feed our model with the data and the model itself it learns an underlying structure of the data. So here you can see we have only X, the features, there is no label here. Then what is reinforcement learning? Here we can see no data. So how do we do it? Let's think about how do you train a dog. So here you can pause the video and think about how do you train a dog. I mean, pause the video, not close the window. Remember, we are going to learn machine learning together, right? Okay, so how do you train a dog? It's impossible that you list do's and don'ts and give it to the dog and say, hey dog, read, and you know what to do, right? So how do we train a dog? Basically, we interact with a dog, and whenever the dog doing something good and you can say, yeah, good dog, good job, and feed the dog with some snacks, and the dog will be happy. And if the dog does something bad, and you can say, bad dog, and maybe show the dog with a sad face or even an angry face. So over the time, the dog will learn what are the behaviors that you like and what are the behaviors that you don't like. Now we talk more about supervised learning. In supervised learning, there are two categories: regression and classification. In regression, the output is continuous, whereas in classification, the output is discrete. And here I list some algorithms that you can use in the respective scenarios. And you can see actually there are some algorithms being repeated. It means that this algorithm they can use in both regression problem and classification problems. But be aware that in the future when you are learning an algorithm, you need to know what are the problems this algorithm can solve. Is it supervised learning or unsupervised learning? If it's supervised learning, is it regression or is it dealing with classification? So, for example, in the future, you want to solve a classification problem and you ask ChatGPT, and ChatGPT say, oh, you can use logistic regression this time. And because you already know the concept, you won't be surprised that the ChatGPT telling you logistic regression you can use for a classification problem. Let's see an example of housing price. So in regression problem, maybe we can define our question as what will house prices be like in my town next year, and the possible outputs can be any number on these lines from 100k USD dollar to 300k USD dollars. And in classification problem, maybe we can define our question as will houses be affordable in my town next year? So we divide it into two categories. Every result less than this point is affordable, and any result more than this point is expensive. Let's see another example of weather temperature in regression. We can define our question as what will be the temperature tomorrow. So the answer can be any number on this line, maybe from minus 10 degrees Celsius to 40 degrees Celsius. In classification problem, we can define our question as will it be hot or cold tomorrow? So any result less than this point is cold, and any result more than this point is hot. Or even we can divide it into more categories. Maybe from here to here it's cold, and from here to here maybe it's cool. From here to here maybe it's medium or warm, and more than this point is hot. Then unsupervised learning. So unsupervised model, it learns the patterns and structures from unlabeled data. There are two main categories in unsupervised learning: clustering and dimension reduction. The most popular algorithm in clustering is k-means. So what is k-means? For example, we have a list. This list represents the people that are going to the party tonight, and we can set k as 3, 1, 2, 3, 3, and the output might be the bachelor students, the master students, and the university staffs. So there are 3 groups. So the model itself, it identifies groups of data points that are similar to each other within the same cluster, while being different from data points in other clusters. Then dimension reduction. Nowadays, we use it mostly for data visualization, and most popular one, or maybe the only one, algorithm is PCA. So imagine that we want to visualize data that is maybe 50 dimensional or even over 1000 dimensional. So how can we visualize the data? How can we plot it? So we have to transfer it from many dimensional to 2 or even just 3 dimensional. Then we can visualize our data. So in other words, it just like find the best way to tell a story using just a few important features instead of showing every single detail. So even you transfer it into just 2 to 3 dimensions, you still have to keep the essential information. Then reinforcement learning, we have already explained. It's like teaching a robot, a dog, to play a game. It learns by trying different things, getting rewards when it does well, and figure out how to do better next time. Then I also share a video. It's a very short video, just 5 minutes, and you can review the supervised and unsupervised models that we have just listed in previous slides. You can watch by yourself later on. Then after we learn these machine learning algorithms, we can start to build our model. And here are the steps that you have to follow. First of all, we have to collect our data. Then we pre-process our data. We will talk about this point later. Then we can choose a model. So as I said, there are many libraries out there we can use. We don't have to code the algorithms from scratch, but we still need the knowledge to know which algorithm that we can choose. And also, if we know the concept of the algorithm, it will help me to know how to debug. Even we can Google, we can ask ChatGPT, but what's the keywords, what the questions that you need? You need to know how to ask the proper question to get the answer that you want. So yeah, that's why we still need to know the concept of the algorithm. Then we can train our model. But remember, you have to split your data into training set and testing set. Why? You can pause the video and think about it. It's me, stop speaking. It's not your internet connection problem. Okay, so the reason that we have to split the data into training set and testing set is like, for example, your professor is very kind and the professor gives you the mock final exam questions and also the answer, so you can practice until you get every single question right. But after you done that, you can not just come to the professor and say, "Hey, professor, I'm very good now. You can just give me full score 100 points for my final exam because I know everything." It's impossible, right? You still have to go to the real final exam and test yourself, like how good that you can be. So it's the same for our model, for our algorithm. We use the training set to train our model, but we need another testing set to check the real ability of our model. Okay, so after we finish the training, we can evaluate our model using the testing set. Then we can check the accuracy and see if the accuracy is okay. If it's not okay, then we have to turn our parameters and optimize our model. Then, after we finish it, we can use our model to predict the future, the unseen data, and we can deploy our model. Okay, let's talk more about the data preparation pre-processing. Here is a very easy example. It's impossible that we use these few data for real life scenarios. Okay, so you can see there are so many missing values in this data. And also here in the country column, even this they all mean Germany, but they are written in different forms. And here, true, false, they are written in different forms. So we have to modify them and make sure they are written in the same forms. Otherwise, if you feed this data to your model, your model would complain. It would say, come on, you do by yourself. I quit. And then feature selection. If we have so many features, some of them might not be relevant to the questions that we want to solve. So that's why we need feature selection. And the same reason for dimensionality reduction. And also, like if you have more dimensional data, more features of data, then you need more time to train. So if you can remove the irrelevant features dimension, then your model can train faster. Also, we need to normalize our data. Yeah, so after you learn the things, then you can start to search for some example codes online, and there are some common libraries that you will see very often. So here I list 4 of them. First, pandas. Pandas, we use it mostly to read our datasets. It has other functionalities, of course, like you can also write the data and export the file. Next, NumPy. NumPy, we use it for scientific computing. And then Matplotlib, we use it as a plotting library. So when you train the model, you have the result, some numbers there, and how to visualize it, we can use Matplotlib to draw the graph for us. And the last one, scikit-learn. Just like I just said that we have so many libraries out there, and scikit-learn is a very popular one. And it offers many supervised and unsupervised algorithms. I also share an interactive cheat sheet here. So when you click on that link, you can see something like this, and it's interactive. So you start from here and ask the questions, and maybe you want to use this one, and you can just click on it and it would redirect you to the page, and you can see the explanation of this algorithm and also some examples there. It's very, very well documented, so a very, very good library. Okay, let's move on to there are some ways of importing libraries, and here you can see actually these 3 ways they mean the same thing, but take a few minutes and take a few seconds, not minutes. You don't need this much time. So think about which one would be the better approach. Okay, so the first one would be the better choice, even though they're doing the same thing, but here you import the function that you want to call. So maybe a few months later, or maybe another person, when that person read your code, it's like better readability. That person can already understand, oh, you want to call this function in your code, rather than if you just import the model and you import the linear regression function under this model later on. Or even worse, you import the library itself and you point to the function that you want to use later on. So the first one would be like better for reading. But for performance part, actually, it doesn't affect your performance that much. It's more about the readability. And here I put another example, so you can take a few seconds and think about which one would be the better approach. Okay, so the answer is still the first one would be better, because you import the function that you want to use here. And the second one is actually from the same model, but it's separate into 2 lines. But yeah, actually you can put it into just 1 line. And the third one, you just import the library and you point to the function that you want to use later on. So not very good to read, to understand. Okay, so that's all for today. I hope you learned something and enjoy the video. See you next time.